Hi, I'm following along with Paul McWhorter's Raspberry Pi lessons, and I had originally done not a terribly good solution for lesson 31 and 32, which is dealing with input from the keypad. My problem with it was that when you look at the keypad, it's 16 keys like that. And I thought, what a shame that the way I've done it, I cannot deal with hexadecimal numbers unless I miss out E and F. So if you make that E and that F, then you have all the hexadecimal digits. But then you think, but how do I tell it that I've finished inputting my hexadecimal string? So I thought, So I thought, first of all, I could make it so if you press more than one key at once, it will do something. Like if you press asterisk and hash, then that will mean that you've finished inputting. But it isn't exactly reliable if you press more than one key at once, because it might register that you press the asterisk before the hash, and then it might think you've taken your finger off the hash, and too confusing. So then I thought, need another way of doing it. And then I thought, you could always be asking for a fixed length string. So in your program you say, right, give me three characters, or give me 4 digits, or something like that. And I thought, yes, but you might not want to do that. So then I came up with the idea of that if you hold down that button for more than 2 seconds, it won't be an asterisk. It will actually be the special character for deleting the last character input. And similarly, if you hold down that one for more than 2 seconds, it will say, right, I finished inputting, go back to the program. So I created myself a very chunky sleeve to put over my keypad, and as you can see, I've made it so you can input colours. You might want to choose colours from your keypad. So there's, you've got white, red, blue, green, orange, pink. Pink, you can tell what pink is, and that's black. And then I've also done it so you can use it as an existing keyboard with the asterisk and the hash. But then there's the other option that you can use it as hexadecimal, so you've got the E and the F. And down here it says if you want to return, you hold, press and hold for at least 2 seconds, and it will do it. Right, that is my keypad. The window on the left is Thonny connected via VNC to my Raspberry Pi 4, and it's just a simple program that uses my keypad library, and it demonstrates all the different methods I have in it. And the window on the right is Thonny running on my Pico. It's exactly the same program, it's just that it was the easiest way to be able to look at both of them at the same time. So if we look at what we've got, that's just the up the top, it's the pin numbers that you're using. And if you go down here, I've got an erase for the keys. That's if it's just the normal standard keypad. And then that is if you're choosing your colours. So for example, white is FF, 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 and black is 000000, and all lots of colours in between. And then the third array is when you're using that key for F and that key for E. Now, what is important at the beginning is you need to know whether you're using MicroPython or i.e. on your Pico, or whether you're using an ordinary Pi. And if you are, you need to import from machine, import pin. The RTC is left over for when I thought that the real-time clock would actually work well on the Pico, but it's total rubbish. Things might get better when you get the Pico W, but I don't know. And otherwise, on the ordinary Pi, you use the GPIO designation. And here that's just setting up the keys. I've set up RTC, don't know why, forgot to take it out, and everything's very basic. This is the normal reading the input that I'm sure everyone has it very similar after watching his lessons. And down we go, down we go. Right, I've created a method called getChar, which just returns one character, and it checks to see whether you've pressed more than one key at once, because that can confuse everything. And then equally, there's getColor, which just returns the code for each color that you choose. Then you've got getRGB, which is the same as getColor, but it splits the color into red, green and blue. Right, then you've got getHexDigit, and that just returns 0 to F. And then you have excuse me, then you can have getHexValue, which will give you the decimal value of your hex character. This is where I hit a bit of a problem, that int of a hex string on a Pi, you have to tell it that it's base 16, and int on the Pico, you don't have to tell it, it knows. Now, I think this is caused by the fact that whoever wrote MicroPython was a C programmer, so I don't know. Anyway, it's a bit shonky that it isn't the same. Then you've got getDigit, that just returns one digit of between 0 and 9. And then you've got getInteger. Now, this is where you use the bottom left to correct and the bottom right to say you've finished inputting. But in this case, you don't have to hold it down for at least 2 seconds, because it isn't a valid input for an integer, F or D. And that's just setting up the array, which you then return to your program, and you're returning it as an integer, because it isn't a fixed length. You haven't asked for a fixed length integer. Then getString is exactly the same, apart from you have to know whether you've held down the bottom left and bottom right keys for more than 2 seconds. And here, if you've pressed the special keys, that one and that one, you start self-timing, and then when you press the next key, or don't press a key at all, you need to check how long the previous key was held down. Now, as the real-time clock is so rubbish, I've had to assume in this program that it's always been held down for 3 seconds, because the real-time clock is just random, a random nightmare, does not do it. But if you're using the Pi, you can start the time when you first press it, and then you can tell how long you've had it pressed down. And then the rest of this is all hello, was it really a D, or am I returning the value? Then get hex string, you're just doing exactly the same thing. You're getting the string and you're adding 0x on the front to tell you that it's a hex string, and hex string value, it just returns the integer value of the hex string that you've input. But there's a problem here that you have to use a different syntax to get the integer value, whether you're using a pi or whether you're using a Pico. Then you can get a fixed length string. So you don't have to worry about the F and the D keys at all, and you just, in the program you say, right, I want a 5 character string please, and then it returns you a 5 character string. And same goes with a fixed length hex string. Then you could get the value of your fixed length hex string. Then you can also get a fixed length integer, and when you get a fixed length integer you have to return it to your program as a string, because that's the only way that you can retain your leading zeros. And if, say, you were entering a pin on your on a machine, and your pin was 0752, then if you returned it as an integer, you'd just have 3 digits and it would lose the leading zero. Anyway, enough of this. We will try running it. So we'll go over to the program on my Raspberry Pi and we'll run it, and it says get individual colours. So if you think, oh, pink looks quite nice, so you press that, and FF, well, probably that's pink, who knows. Get character, if you press A, it's A. Get colour, if you try again, if you press 1, and that's white, that's FF, which is quite lucky. Then get hex digit, so if you press E, you get E. Right, get hex value, press C, which is lucky because C in the decimal value of C is 12. Get digit. Right, you can go A, B, C, nothing's happening, F, and the program ignores it until you actually press a valid digit, which is 5. Get integer. Now this is when you can just go B, 4, 6, C, 7, 8, and then you think, oh, I didn't want the 8, so you press the bottom left hand to get rid of it, and then you press D, and that was 4, 6, 7 without the A's and the B's, and it got rid of the 8 at the end. You don't have to hold it down for at least 2 seconds for the integer, but it doesn't hurt if you do. Right, how long an integer? This is when you use the keyboard, because I'm simulating it coming from the program. So you click there and you go, right, I want a 5-digit integer. So you go 1, 2, 3, 5, B, O, C, oh, nothing's happening, 4. Yep, that's because it ignored the A and the B and the C because it wasn't valid for an integer. How long a string? Right, 7. And, oh, incidentally, I haven't put in the correcting keys for a fixed length string. That's just how I did it. So you can go 1, 2, 3, A, B, C, 4. Yep, that's 7 long. How long a hex string? 3. So you can go A, B, C. Yep. How long a hex string value? Oh, we'll go 2. We'll go A, 0, 160. A is 10 multiplied by 16 plus 0. Yep, that's right. Now get string. This is when holding down the D and the F key comes into play. So you can go A, B, C, D, 3, 6, 6. Oh, I didn't want that 6. So you hold down the left hand bottom for at least 2 seconds. 1, 2, that will be long enough. And then you put an 8 in instead. Hold down the D button. Right. And you can see that the D there has actually appeared in the string because I didn't hold it down for 2 seconds. Right, get hex string. A, B, 6, 3, E. Hold down the D. There. Right, get hex string value. So you can go 0, 0, 0, 0, 1, 0. And hold down the D. According to me, that should be 16. Yep, that's lucky. And we're back to the beginning of the loop. So there you have it.